We're on. Hi. Welcome to tomorrow's Sustainable Housing Today. I'm Cynthia Figge, and I'll be moderating this discussion with Hank Lewis, founder and director of DesignBuild Bluff, and also professor at the College of Architecture and Planning at the University of Utah. Welcome.
Thank you.
And Mark Foster, partner at ZGF Architects, which is a worldwide architecture firm with 380 people. So we're going to talk a little bit today about the future of housing and buildings in the US and around the world. And this may be one of the most important issues that we face, given demographic changes that are occurring, the press for reduction in carbon footprint, urbanization, and severe income inequity around the world. So today, maybe very few of us know that buildings consume 70% of electricity, and 40% of the world's current output of raw materials go into buildings. So the footprint, both water and carbon, is tremendous. So I thought we'd start it off, Mark, if you could perhaps give us a little bit of a lay of the land and
Sure.
Maybe paint a picture for what the housing and building market looks like in the United States and then around the world.
Yeah, and I would start by adding one other factor here. Aside from the energy or electrical energy consumption, that in the total energy picture, buildings are responsible for the consumption of nearly half, 48% of energy consumed in the United States. So if we can cut this by 50%, that's like taking out all of the transportation energy costs. It's a very significant issue. The chart up here is sort of part of the context, and that's the urbanization of global populations. And in 2008, we actually crossed the line. We're now more than 50% urban, and that's expected to rise. The primary growth, of course, will be by number, China and India, but the United States actually has a considerable projected growth rate, another 100 million people, and we are already 80% urbanized. Another factor involved in this is that a huge portion of the existing housing stock around the world is, in fact, substandard. So there'll be a big demand both for new housing and for replacement of existing and renovation of existing. And what this is leading to are projects like this that we're doing around China. This is 4 million square feet of housing, about 4,000 units. And we're a relatively small player in this. So the context is urbanizing, population growth, high density urban housing. That's just what we're going to get. And it's not only true in other countries. This is true in the United States as well. This is a project we recently completed in Portland, Oregon. It's 270 units on half an acre. And it's not really unusual at all. There's a lot of projects like that. This one, we'll talk about a little bit more, has a lot of sustainable features that went into the planning of the project. Recently received a platinum rating from the US Green Building Council. Related to sort of the fundamentals of the demographics is the supporting transportation infrastructure. And this is just to point out that this particular chart is, I believe, gigajoules of energy consumption based on city density. So you can see the yellow cities are all the United States, and the most efficient transportation infrastructure is in New York. And then, of course, all of those are relatively inefficient compared to Australia, Europe, and most importantly, in Asia. And then there's another feature in the context for the United States, and that is what we have. We have by one guess, the Urban Land Institute suggests that there are probably 50 million houses in the United States where there are more bedrooms than people than live in the houses. So we have a big capacity, and many of them are built in the wrong place.
Right. Yeah, Hank, I think we'll just switch gears here, because I think you've been doing some work that has evolved over these past years that has some real implications for sustainable housing. But please share what your organization, DesignBuild Bluff, does, and what you've been preparing students for.
Thanks. I find it really very ironic to be here at a tech conference, because tech was actually what pushed me into this, honestly. In the early to mid 90s, I saw students coming out of school with the advent of the computer, and I thought they were just playing around with it. I was seeing portfolios that looked like fun with Form Z, and I thought that the students might be losing touch with actual sense of building and understanding of how things are put together. So we started DesignBuild Bluff, and as Mark and I were talking yesterday, this issue of sustainable housing can be, or at least, we were talking about maybe 50 to 80% can be solved, very, very simply just by super insulation and the correct orientation and things like that. So, very, very simple ways to do it, and that's really what I'm interested in down at DesignBuild Bluff. We take students, graduate students, first-year graduate students, to the Navajo reservation, where they select a family and then design a house during a whole semester, and then the following semester go down and build it. This house here was just completed actually last year. It's all designed by students and built by students, and you can see. I think that the spirit of the idea of the house really sings, and actually it works quite well. It's lengthened east-west, so that there's passive solar and catchment in the south, and there's the interior. You can see that we're actually going back to learn. It's kind of a step back to relearn from the vernacular what things have been, what's been happening. And you can see this house, we used rammed earth, actually is doubling as both the structure and a kind of a trom system, so that it will use the flywheel effect, so it'll heat up during the winter and cool off during the summertime. Stretched out lengthwise so that we get natural ventilation. You can see that large roof is working triply as a shade structure, as a water catchment system, and actually cooling off, because it's a double roof system, and it helps keep the sun off the lower roof. And this is a shot of just the interiors. This was built out of a very interesting material called Flexcrete, fly ash, autoclave block. So our students are trying to explore different alternative materials, alternative building systems, and I find it really to be more of a springboard to the firms like Mark's that will begin to work more smart systems and things like that. So that's what the students come, they're self-selected, so they're obviously very interested, and I'm encouraged by that.
Yeah, I'm not sure, I missed it. These homes are off the grid. Had you mentioned that?
Yes, well, they are off the grid. We moved to the Navajo reservation. I don't know if I mentioned that, but there really essentially is no grid down there. There are power lines in certain places, but the Navajo live all spread out, which is interesting to me. They will not congregate. It'll take me another 5 lifetimes to really learn that culture perfectly.
Yeah.
So yeah, they're off the grid, and that's serendipitous to us, because the students then have to figure out all of those systems too.
So if as we move from a world of 6 to 9 billion people with the vast majority of that increase in humanity being in the less developed world, what applications are you finding for the work that you're doing with your students elsewhere in other parts of the globe?
Well, yeah, I think it translates obviously, and we're all talking about scalable things, and we're moving more toward trying to work on prefabricated issues down on the reservation. I've been invited to Uganda to come. They've come to DesignBuild Bluff to see what we're doing. They've invited us to come to Uganda and try to help them with their housing situation over there. I've been to Guatemala and Costa Rica both. Costa Rica doesn't seem to need that much help, but Guatemala certainly does. So yeah, hopefully we'll build it into a global system.
Yeah. What's your sense, Mark, given the need for radical reduction in the carbon and water footprint of buildings, and also both the need for it and the capability, how will we get to net zero power and net zero water in buildings?
Well, there's a number of strategies, and one of the things that was really interesting about Hank's photograph with the butterfly roof, when he mentioned 3 or 4 things that it does together, the idea of an integrated design approach or sort of cascading uses of resources. On the building I showed in Portland, there is a roof garden which is nice enough for the tenants, but it also filters rainwater. The rainwater is collected. It's kept in a 60,000-gallon tank. 30,000 of it is sort of the base coverage for emergency sprinkler systems. The other 30,000 is reused to flush toilets. This is about 275,000 gallons of water a year that we do not take from the city. And the system was pretty much paid for on day one because of city agency system development charges of nearly $400,000.
Yeah.
So there's a couple of things here. One, it can happen pretty rapidly, and it's not net zero water, because there are still times, of the year when it doesn't rain enough to kind of keep it going.
Even in Portland.
Even in Portland. And actually, it's kind of one of the downsides of the vertical building is because you have your footprint to total gross area ratio is diminished.
Right.
So your catchment area goes along with it. But there are a series of initiatives out there. One of them is the 2030 Challenge, which is a challenge to the building industry to reduce the carbon footprint to zero, phased in over the next 20 years, from an immediate 60% reduction from standard building practices in 2010 to 100% reduction by 2030. And there are a lot of designers, university, and public institutions that have bought into this.
Yeah.
And then there is another initiative called the Living Building Challenge, which includes net zero water, net zero energy, and on the net zero water, there's also, it needs to be, any discharge from the site also has to be environmentally safe.
So do you see, the pressure for change, is it coming really externally, or is there a demand pull from consumers, really? I mean, I think about growing up and with an 1,800 square foot home with certainly less bedrooms than there were people.
Yeah, that's completely different now.
And it's completely different now, and bigger is better. And so how do we deal with, I think, the incredible shift in...
Yeah, and it's coming at a fascinating time, too, because we do a lot of housing, residential housing on university campuses, and almost everybody there that's coming in today grew up in one of those houses with more bedrooms than people. So they all want their own room on campus, or they have higher expectations for it. Their energy consumption is greater. All the old dorms only have one plug. So, how do you get all of your appliances plugged in? But at the same time, there is, in fact, a very big demand when those people leave college and from the development market for more efficient buildings. I mean, if you don't have to pay system development charges and so your building is also then less expensive to operate, the demand is going to come from the real estate developers and building owners. And that's where we see it coming from. It's not just that it's like a neat idea that university students are talking about. It's that too.
Yeah.
But as the technologies evolve and are demonstrated to be cost effective, it makes it a lot easier. It doesn't reduce the challenge of getting to net zero in any of those resources.
So, Hank, what's your sense of what are the students really taking away in addition to the incredible experience of really designing and building a home from start to finish? What are the students taking away from that experience? And what shifts are you seeing in that younger Gen Y group?
Well, certainly, I find it was interesting that when we started this program that it was more really about learning, you know, how to build what you design. You know, there's always this rift between builders or contractors and architects, and you know that seemed to me fairly absurd. You think back to the master builder. It should be one kind of entity that's actually in charge of constructing what we're all living in and working in.
Yeah.
So you know, I think you know, that litigious nature seems to be a little bit gone from this Gen Y, I guess, generation that you're calling it. They come, as I said, it's a self-selecting group, so I'm encouraged by how they arrive and they've fully embraced the 2030 challenge to become net zero by 2030. And when they come down and actually physically build these houses on the reservation that are off the grid, I mean, earlier I heard in the talks this idea about failure and how you know how you really have to allow them to fail, and they can fail very, very well down where we are. You know, I saw a great film, Art and Copy, that said that they pushed out buttons called that said "Fail Harder" last year at Sundance. But so yeah, they'll actually understand from things that that we haven't done perfectly well, and so they'll go out and get into firms like GGF and remember what they'd gone through and the effort that they'd gone through to try and, you know, say wrap a earth building with rigid insulation. I mean, you know, something like that, and they'll think, oh my God, yeah, we can address this in design, in design, and the fact that design really doesn't end. After you finish your drawing and hand it off to the builder, I think the design process is always going on during the buildings.
Right. Let's shift maybe to the role that companies play in the future of sustainable housing. To what extent, Mark, are corporations' decisions around both where they site their companies and also how they build those structures and then the ripple effect and impact on housing? I mean, what are you seeing as some solutions there, or some examples of best practices, if there are any, or worst?
Well, I don't know that they're the worst, but a good example of a company that had a big impact on sort of housing development patterns is Nike, who could easily, given the kind of work that they do on their campus, could in fact have located in downtown Portland. They might not have been able to sort of establish the kind of identity that they did by locating in the suburbs, but the travel costs related to that and the kind of housing that went with it in the suburb was pretty significant. It's not unusual. I don't think they can be faulted for, taking a really wrong turn, but it was a fairly standard kind of decision.
Yes.
And I think as companies become more aware of the impact of everybody's behavior on the issues of sustainability and resource consumption, it will add another level of criteria to the decisions about where to locate,
Right.
just as it does to the kind of materials that are in their supply line.
Right, right. Are you doing anything that relates to a kind of a higher systems level where buildings as a part of the larger ecosystem and efficiency within a city or community, any work that's going on there?
Yes, actually there's quite a lot. One place where that happens a great deal is on university campuses because they're already sort of a self-contained community.
Right.
And they have usually their own systems for power and water and distribution of those systems.
Yeah.
But even in cities, there are sort of what are becoming called eco-districts where or district-wide planning is being put in place so that everybody in the district can benefit. It may be that the waste heat from a manufacturing process can be used to heat water, to heat housing.
Right.
So it's different uses and different times, and matching those within a district is a very effective way because the scale issue here makes the efficiencies even greater.
Yeah, yeah. We talked a little bit about last night about just how these hard economic times have been somewhat of a platform for innovating and for working within the constraints. Hank, any thoughts on some fruitfulness that has come through this, and also maybe just touch upon some thoughts that you had shared on the social empathy part of what you've experienced in your work?
Well, yeah, certainly this new group of students are feeling the social responsibility. We talked a little bit about maybe they're coming at it from a more pessimistic view, but I'm not terribly certain about that. I think I do believe that this, for architecture and for design, that the post boom. Maybe that's a better word than just the economic collapse. Has really been helpful for. We spoke about for new planning, being able to step back and actually really look at things rather than moving along in a kind of a fast track way, which it seemed to be that way for several years. So now, yeah, I think it's fortunate. I think the historic preservation group, that it's helping that out. We're going to be using old building stock. We're going to be retrofitting things, buildings rather than throwing up new, brand new stick frame buildings. And Mark and I talked yesterday. Only 5 to 7% of homes in this country are actually designed by architects. So, I think
far too few.
We're hoping.
Absolutely.
Even beyond the economic or the financial ramifications of that, it really needs to go up in order to meet the sustainability challenge, certainly.
Yeah.
I wanted to pile on just for a second there that in terms of the economic environment having an impact on this, probably everybody's been aware of the reports of people who, when money was free 3 years ago, bought a house bigger than they could afford,
Right.
20 miles from New York or 40 miles from New York because they finally could do that.
Right.
And now, it turned out to be a really bad thing, both financially and environmentally, because now they have to drive 80 miles a day.
Yeah.
And now if they can no longer maintain their mortgage, they have to move back into town. So it's not all a bad thing, in the bigger picture.
Right, right. So any recommendations for those of us homeowners who have the desire to improve the efficiency of our homes? Any words of wisdom at that level?
Well, the fundamental thing when you look at designing buildings that you really want to be efficient users of resources is to reduce the load. So whatever you can do, if you have an existing house it's kind of hard to do, but you can, obviously, you can modify your behavior, you can modify your landscape. That's one of the main things to control heat gain, to control, wind that might be pulling heat out of your house.
Yeah.
Hank mentioned earlier, doing things to control air infiltration, because that's any time of the year can have an impact. And there's a number of appliances, the sort of energy smart stuff. All of those things can contribute, but to a certain extent, if this is an existing house, that's the context you got to work in.
Yeah.
And there's a long list of very standard and available strategies you can apply.
That's great.
But we also talked yesterday also about, perhaps there'll be, shortly there'll be insulative cladding systems that maybe we can put on our buildings that are leaking so terribly. I think those innovations are really right here, and that's probably another advantage of being able to step back and begin to really look at things like that we're going to need to do, rather than just flying willy-nilly and building so many buildings, so many irresponsible buildings, really.
Yeah.
There's a lot of technology that's being developed in the commercial sector, or either for housing or for laboratories or any other kind of large building that I think ultimately will also end up in the residential market. Residential market is incredibly dispersed, very unorganized, rather primitive.
Yeah.
But whether it's just high performance glass that works its way into general acceptability in the market, something easy to do.
Yeah.
We were talking about the Passivhaus system. It's a German system that triples the amount of insulation in the walls of of a standard house. It's a hard thing for current home builders to adopt, but over time they can figure that out. Or, as Hank suggested, becomes, rather than making walls that are 2 feet thick, you insulate around the outside. Something we do on commercial buildings and educational buildings all the time, so that you can maintain a mass within the insulation envelope, and that can help control the temperature swings.
Well, it's exciting to think about the work that you're doing, both of you, in terms of getting at that 50 to 80% reduction on this hugely important challenge. We've got about 2 minutes left, so I thought I'd open it up if there are any questions.
Yeah, we got one.
I do. Hi. It's a very interesting topic and discussion, and I didn't hear much discussion about using anything about recycling for construction.
Materials?
Yeah.
Yeah, thank you.
There's two major things there. One is the construction recycling, so that as you are building buildings, there are ever-increasing requirements for the recycling of building materials during the construction process. In parallel to that, there is growing concern that the materials you use to construct the building are recycled and recyclable.
Right.
But it is a major part. Almost every one of these initiatives, whether it's the U.S. Green Buildings LEED rating system or the Living Building Challenge, assumes and gives you credit for your use of and material selection. Also, location of material source, and the distance, the sort of embodied energy that goes into those materials.
Right.
Yeah, we're very focused in on the embodied energy idea and try to use earth, because that's the major resource, and sun, the major resource where we're building right now. We also use, I mean, you didn't see it in the photographs, but we're using old pallets and things like that in the ceilings. We're using really sort of high-tech recycled materials like monopan coming from Germany. It's interesting. Students can actually excite lots of companies, and they'll call them. And monopan in Germany actually drove the material down to us. It's 100% recycled, beautiful, translucent walls. So it's kind of an interesting. Juxtaposition of us using rammed earth and then this really high-tech monopan material. It's fascinating.
Yeah, yeah. Yes?
Jay Pritchett, ceramic engineer from SPI. And one of the two things. One is that most of the problems with insulation is that the system, or the house, exterior is allowed to heat up first, then we try to control the conduction of that heat coming in. Would it be better, and it has been better from ceramic engineering, that we coat the exterior of the house or the exterior of the walls or roof so that there is no heat load. If you block the heat load, you don't have a heat transfer. So we've found a Supertherm, it's a super insulation coating product that does this and tested by DOE to prove out. But that's one thing. The other thing is, have you used any shipping containers?
We've actually, excuse me, yeah, we've used shipping containers and Supertherm actually to coat the outsides of them. Yeah, so that's worked pretty well, and we're actually monitoring that right now to see how it works.
And your principle of reduce the load first,
absolutely,
is whether it's on the demand side or controlling the side that's imposed by nature.
Yeah. So
absolutely.
I'm sorry.
Well, I'm the developer of Supertherm, so thank you very much.
Okay. All right.
Okay, thank you. I'm sorry we're out of time. Sorry to cut it off, but thank you so much. I look forward to hearing more.